Right, the method of graphing is not optimal. Notice that the solution of the system corresponds to the points of intersection. All of this is going to depend on how well we can graph. We will, however, look at the points using a function on the calculator. The method of graphing, to use the calculator, we have to solve both equations for y in terms of x. Using a graphing utility, graph both equations, use the intersect feature or the zoom and trace feature to find the points of intersection, and check that each solution satisfies both of the original equations. Right, for example, let's suppose that we do the following equations. X minus 3y equals minus 2, and 5x plus 3y is 17. Now, to use the calculator, we've got to solve for y in both cases. Now remember, the calculator can help you solve for y if you need it to. I'm doing it by hand right there just to remind you of how it's done. Now, we go to the calculator and we're going to store both of those equations. We now have both of them stored. Then we're going to go to the graphing part, the y equals, and we're going to do 6 zoom standard so that we can see both things, and then we're going to look at how we find that point of intersection using our calculators. All right, there's our two lines. There's our point of intersection. You're going to go F5, and then you're going to hit option 5, which is intersect. Okay, you see it there? All right, now it's going to ask you for the first curve. So let's just use whatever it's pointing to as the first curve and hit enter. Then it's going to ask you for the second curve, and it points to the second one. Now you say, why's the bother? Well, if we had 3 or 4, we could pick out the one we want. All right, it's going to ask you for a lower bound. Please notice, this is a point to the left. Then we have to use our arrows and get down here to the right for an upper bound. Hit enter, and it's going to find that point of intersection. So the solution in this case is 2.5, 1.5. The calculator really helps us on this. Let's look at another example. Here's one where we have a x squared plus y equals 1, x plus y equals 2. Again, we have to solve for y in both cases. Go to our calculator, put in the 1 minus x squared, put it in for y1 of x. Put our 2 minus x in as y2 of x. And then we're going to graph them. Notice there they're sitting just like we want. We will zoom standard just like we've always been doing. There's our parabola, so the curves do not intersect. Hence, we have no solution again. I believe we tried this one before, and we still don't have a solution. How about that?